Hello, everybody. Today I want to talk about the GPT-5 lineup of models, how I am using them end to end on a day-to-day basis, why I have picked them as my main driver when I used to use Claude mostly, and then we're going to go through how I am working like over the day. Specifically, I'm interested in showing off the GPT-5 Pro version of models, which I find to be the most intelligent and capable models that we have access to today. Of course, they are extremely expensive, and we will get into all of the details there. So just a little bit of an intro on myself. I have been working in tech for the last 8 years, and for the last two, I have been mainly using LLMs to do practically everything from research to development to QA to writing. There is very little that I won't use LLMs for, and I think the only exception is like personal writing. Like if I'm writing on my blog, I am the one writing it, or on my Twitter. Where I think a lot of people are missing context, they're missing the knowledge of how to use these tools comes with the more expensive variants. So for example, here we have GPT 5.2 Pro. Now I am using a tool called Super Whisper. You could see it here. This is how I talk to the models generally. I'll open this, there's a hotkey for it, and I will describe what I want. Now we are going to maybe show an example. Now this is great, but I need 5 more research articles that use some different logic and that might go really well with pruning to get a model to be as small as possible. So this is me creating a prompt. Obviously, this is going into a chat that has already existed, and I don't need to do anything complicated, but this was all spoken in directly. You can see that with all the ums in, this is when I'm talking into the mic, I'm saying a lot, but it generally gets what I'm saying, collects everything, and then sends it over to the model. So here you could see that it thought for 28 minutes and 28 seconds. The prompt was, I want you to dig into the literature and research in 2026, specifically around model quantization. What are the newest quantization methods? So I'm aware of AWQ, GPTQ, all of the autoround, all of these different types. I am aware of. I want to find different types. So things that aren't really that popular. And we'll get into why I'm doing this later. And it goes off and it does 28 minutes of research and tool calls. You can see that here. All of the sources that it's going through come up in this sidebar, which is very useful. It's very good to have this trace so that I can track essentially what the model is doing really. How did it end up on the sources that it did? Are these sources valuable? What is the reasoning behind it? Now, it does this for 28 minutes, 30 minutes, 2 hours. It varies a lot, and then it comes back to you with a response. This is great and all, but I want something that's actionable. So I use this to skim over the kind of context that I'm looking into, which is how do I compress models to run them on my hardware. Once I do that, I will follow up. So typically a follow-up looks like picking one of the different options that it gave me and then asking it to create a PDF with a scope of work, a starter code base that could be useful, and just like a bunch of details and documentation and sources to add them into a zip file and send it over to me. Now you could see here I'm asking it to follow up, and it goes for 84 minutes, right? You could see that it has checked 5, so it knows what it needs to do, and it goes online and it starts running bash commands, it starts reading files on the internet, and it will come back then with the details that I requested, and when I click on this PDF, it will open it, and I can read the PDF, and it's typically the highest quality output of any LLM, which is the goal here. This model is the most intelligent LLM that we have access to in today's market. Maybe DeepMind could be more intelligent, but I've never gone to this model and have been let down. That has never happened to me. Everything that it puts out is typically correct on the first go, and if it's not, Codex is able to fix it within a few minutes. Now, you could see here that we have all of the different basically paths that it picked. It picked a PDF for each, and then from there I can go in and I could follow up with new files. So I like to create projects. Projects are just like folders, you can imagine them, that have files and chats. This project here is a follow-up in a way. So I'm asking how to get DSA, which is the DeepSeek attention, working on Ampere. Ampere is the GPUs that I have access to. That isn't like possible by default, but I want it to run, and so I can ask this model, and you see it went and did reasoning for 69 minutes. That's funny. That's funny. And you can see here that it's looking through all of the sources, doing all of this thinking, and coming back. Then it produces these bundles. So this is the code zip. These are the PDFs. And then I copy those. I read about them. I do my I need to spend time understanding the problem and the scope of the problem. Once that's done, we can then, like we said, install it, get our content, and we can move on to the prompting side of things. So right now, we are going to go into the DSA project to take a look at the outcomes. So I will typically use Codex. There are very few situations where I use Claude these days. I go between them, obviously, like it has its benefits, but now that I have this, I will be able to do two things. So first, let's take the research output that it gave us. I want to take this and I want to go into my browser. So these are all of the different browser tabs that I have open. I'm going to create a new one, and this is browser automation. So I drop in what I'm looking for. This is the output that the model had given me, and I can tell it, please do more research on this and let me know if anything is wrong. Yeah, it's okay. I'm gonna have some typos here and there. Kimi K 2.5, and I will run this. So now the model, this is another LLM, right? We'll actually get into something in a minute that's interesting, but now I have the research. I need to be able to fact check it and dig deeper into it, because even GPT-5 point whatever Pro still has issues with like including links that could be dead, missing something very obvious, because it is using curl. From my understanding, I'm not sure what's happening under the hood, but I think it's curling and using web search. When you have a browser, there are all these different like connections and details that you wouldn't get. So this links, for example, to some other papers that are relevant that wouldn't come back if you just Google whatever, regularization, calibration with successive rounding for post-training quantization. So when you search that on Google, you might get this document back, but you might not get it in the context of being within RxIV. You might get a PDF, and that will prevent the model from having full context. So being able to navigate a browser similar to what a human would do, we can then have better outcomes. Now, you can see here that the model is running. It is doing its thing. It is clicking around, it is navigating just like we would essentially, and fact checking this information, and then it'll come back to us with the results. And while we're waiting for that, we go back here, and you can see that I have GPT 5.3 Codex. That is the model that I am running. Now, in order for me to know that what I am doing makes sense, because these LLMs, they are capable of tricking you into believing that you are like, you have good progress, that things are going well, but you really never know. So you have to dig into everything that they are doing. So if you see here, we have benchmarks, and these benchmarks, they run against like whatever. Sometimes it runs against, like it depends on the type of task, but here I'm checking the GPU speeds for generation and like calculations, and then comparing them against speeds from the DSA on Hopper architecture. And what that gives me is some confidence that where I'm going is the correct path. I don't want to put all of my eggs in the LLM basket and expect it to just be right up front. So I have to spend some time validating and creating these verification runs. Now, once we have the scope, like we've been discussing, the next thing is taking that idea and then figuring out how to implement it in reality. And what I do next is I go into plan mode. Once I'm in plan mode, this is the time for me to think and for the model to communicate with me. We are going to discuss, let me go back into Firefox here. I'm going to go into this CUDA and let's see. We will open this document and we will drop this here. How close is our repository to being in a state where we can test this out? Now we have 83090s that are mostly in use all day. So in order for me to do anything, I would probably need to rent out a few GPUs. Given that this is Ampere, I would probably need to rent out some specific A100s maybe. What would you recommend? And then tell me, like, what have we done over the course of this project? Where are we currently at? And then how do we wrap it up? So using plan mode with the models, like I've heard from people that it is not necessary for the models. And maybe I agree with that. Maybe GPT doesn't really need to plan. It's good enough at like maintaining and managing its own context window, which is what you need, right? From a model, you need the model to be able to find what it's looking for. You need it to take the right decisions, explore the right, explore the right spaces. So I will give plan mode on for myself because then I am in the loop in terms of what is going on. It's less of me delegating a task to a model. It's more of me trying to collaborate with the model. It still takes a long time for it to go and get the context of what is going on. But once it does, then we'll be able to go back and forth and come up with a plan. We're going to be able to save that in the actual disk. Like it needs to be a file that is on your machine that you can edit, because these models, they can compact, and when they go through compaction, what ends up happening is it forgets a lot of the information. So if you have a document that has the plan in it, you can then yourself validate, verify, check, and then pass it back to the model, maybe start a new session, maybe switch to Opus. It gives you a lot more freedom. So now it is searching the web and it is trying to find prices of these GPUs. Another thing that's important here is to give your model as much like freedom as you can, because as you can see here, this model needs to search the web so that it can validate things. With Codex, for a long time, unless you gave it explicit permissions, it would not search the web. Like you need to go and turn on a flag somewhere. So you need to understand that and know that and then work for that to prevent an issue where you're just getting back responses from its memory. Also, slowing down using plan mode helps because then you can actually listen to the model and what it is asking. And when it gives you a multi-choice question, it makes it easier to understand like what it is trying to accomplish and also correct it if it's wrong. So here it's asking what should the rental plan optimize for. Let's see. We want a demo ideally, and we can also tap to give it a question that it didn't ask. While I'm doing this, we can go back to the response here and we can see what it's saying. So the research findings are that nano quant implementation guide verification. After thorough investigation, I can confirm that the document you provided is authentic and accurate. All papers referenced are real. This is the most important thing and something that people commonly complain about. It checked all of the different pages and it told me what is real, what isn't, when it was submitted. And I'm looking here for specifically papers that haven't been validated in real life. So they've only been around for a few weeks. And I can look through what it's saying and I can get the pages and it's good enough for me. So from here, I want to demonstrate something else. Now, let's say I am trying to find the cheapest GPUs on the market right now. I've switched to 5.3 Codex Spark. This model has been such a blessing to work with. It's really changed a lot of the way that I work in my terminal and in my browser now. I used to like open tons of different projects and also tabs. I still do, just I'm not switching as much because if I want instant feedback or like very quick feedback, it's fast in the browser, but it's really fast in the terminal. And we'll visit that in a second. I need you to please go find wherever the cheapest place I can rent 8 A100 GPUs from, and I will let it go and do its thing. So this is a browser automation tool that I am building, that I have been building. I built it because working with the Claude Chrome extension has been very difficult. It is amazing. I learned a lot from it. I'm very grateful that they built that thing, but it's running from like an IP of not a non-residential IP, so they get blocked from interacting with a lot of sites. There's a lot of issues with it. So this is a browser extension tool that just lets me do the same thing of like, here's some information that I need, and now I'm gonna walk away and go back. So for the 8 GPU demo, which model scale do you want to lock in? Use a smaller GLM5, DeepSeek like MOE to prove full frontier size target. So what I'm doing here now is, let's say I want cost first. It must also be Ampere. So this is going to be like what I'm doing over the next like hour or two. If this was a real workday, which it kind of is, I guess, we can also go in here and I can demonstrate something else, which is this model, which I am so blown away by. I've used a lot of the Cerebrus model. I've used all of the Cerebrus models actually, and I find them to be very good. They have issues, or like you need to approach them from a different perspective, given that as soon as you prompt, whatever you ask for is kind of done. Explain this project to me with machine state diagrams. And let's see how long it takes it to do its thing. So, oh, I actually went to the wrong model. Let's go with Spark. And let's go there, and it should be fine. So now you have this incredible speed that you can basically ask a question and then jump over to another file and then read that file, and by the time you're done, you have your response. And what this is helpful for is like staying in the loop of what needs to happen. So now it's opening DigitalOcean. Oh wow, okay, so this is actually Spark controlling the browser. It's using the skill for Playwright, and it is opening stuff in the browser. It's fetching, which is very interesting. So this model lets you stay in the loop, and it lets you have like a good idea. Make it ASCII instead. We need markdown diagram rendering, so that's much better. So now it's instant feedback, right? You and the model are essentially the same thing. This is how I've been using this model, is like just get this thing done as soon as possible. I've used it to iterate on UIs a lot. I've used it to iterate on ideas even. I've used it for learning because I found that like as soon as I ask my question, I get my response, and that's been so helpful to actually like pay attention. I have problems paying attention and I get bored and I just jump to the next thing. But having something that is able to match your thought speed is incredible. So now it's going to give me this ASCII version. I'm going to look at it. So this is how I work. I run one long-running task for code. Let's say good constraint, A100 is Ampere, so it fits your requirements. Update recommendation must be Ampere locked. Okay, primary choice, run blah, 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 Ampere dev loop, Ampere end-to-end. Let's implement this plan. And so now I have this long-running process kicking, and I will open typically like 2 or 3 of these at the same time. Here I have clean type checks. Let's see. And let's see if they actually fixed it. We can go here and we can go. So this is not the production version. This is my local development version, which is a lot more buggy, a lot less consistent. Yeah, unfortunately. Can you explain the different GGUF quants by, what is it? What is the company called again? Let's see. GGUF by Unsloth, yeah. Can you please get the GGUFs from Unsloth, take a look at them, and then explain to me what they're doing and why their quantizations are so popular? Try to be precise and technical. Create this in some form of visual artifact that I can look at and understand pretty easily. Okay, Hopefully now this works. It's just going to take some time. I'm trying to test, but I need to take a screenshot of this. And so this is essentially the way that I've been working. The main work that I'm doing has all been driven by the model, the GPT brand of models. I've been using Claude actually for things like so this is debugging, and sometimes I use Claude for this, but Claude has not been able to solve the problem. So I'm going to use Codex, YOLO. Life hack is use the YOLO thing. Let's see, what is the problem? When I use the model step-3.5-flash, I keep getting errors related to JSON. So JSON parse error, unable to parse JSON string. This seems to be an issue on the controller end. I would like you to take a look at it and see where it's coming from, and then tell me how you can fix it. And now we give it to the model and we go back and forth. So I found that this model is probably like my favorite right now. This one, Codex and Pro. And using them in combination, I can do pretty much any technical problem, right? Like this is not hard for them anymore. If we go to look at Hugging Face, we're going to look at the models that I have personally released, mainly to demonstrate something. So I don't know much about this world. Like I'm doing this as somebody that enjoys it more so than anything else. I just really enjoy this type of I like playing around with these things. So one day I wanted to run GLM 4.7 and I was thinking, okay, well, we need to scope it out. We need to, there's a lot that goes into it. You need to rent GPUs. You need to get calibration data. You need to make sure that the way you prune is not conflicting with the model's architecture. And so I basically gave the task to GPT-PRO. So let's take a look. Reap, and I will get to see which one, hopefully it catches it. So we want the one sometime in prune before quantization. I think this might be it. No. Yeah, this is going to take a very long time to find, but it's probably important for me to do so. So 1412 DSA on Ampere quantization model analysis, non-NVIDIA GPU. Calculate. Okay. Quantization model analysis might be the one. So yeah, I give it basically the scope of work and I tell it to go and do the research and then come back to me with what I need to implement. I take that, I then pass it on to Codex. I tell Codex to plan and build out the environment that you are running these experiments in. So you have to run an environment specifically for the experiment. Use Docker, create some kind of visibility to everything that you're doing, because if you don't, the problem that will eventually accumulate is the models make a mess, and you need to basically be their guardrail. So have Codex build out the environment. I use GLM a lot, actually. So GLM is so much similar to these GPT models. The higher the reasoning effort that you give it, the more it is capable of surgically removing something and addressing it. It is capable of tasks that run for 2 to 4 hours. I've done this myself. I used the GLM model to take 2 different servers and a bunch of configurations that were on DigitalOcean and Hetzner, and then to move them over to AWS, and then to change all of the configurations for this server. And that was a lot of work, and it was 3 prompts and 2.5 hours done very quickly, very efficiently. It would have probably taken me a few days to do it myself. So hopefully this gives you an idea of what I think a good workflow looks like. This is how I have been learning and working, and this is how I think I will continue to work. I think that if you are trying to get into serious engineering and architecting, you need to work with the GPT models. They are more difficult to work with. They are less pleasant to talk to, but they are extremely intelligent. And the Pro model, especially if you can afford $200 a month, is simply like an oracle. There is a project called Oracle by Peter Steinberger, I believe, who he spoke about the fact that it's like an oracle, and I agree with him fully. There's nothing that it gets wrong, and but the GPT 5.2 Codex, 5.3 Codex, they are catching on. And the Spark model is going to be a revolutionary change in how AI coding and AI research and like browser automation is going to go into the future. I wanted to give you guys this update and try to help you explore new ideas. If you have any questions, reach out to me on X. That's where I'm mainly at. I will leave the link in the description, and hopefully I will see you again in the next one.